We have talked a little about the impact of COVID before, but this is a series of papers that came out that have looked at various impacts of COVID lockdowns, reduced mobility, reduced human activities in general on various climate and environmental variables. There is also a proposed effort for the research potential of the biologging initiative. Basically, they are trying to make a quick assessment, monitoring to quantify the impact of changes in human activities on various ecological fields like avian, marine, and terrestrial biologging studies here. So this map in the top shows locations of a subsample of active animal tracking or biologging studies superimposed on human population density of obviously high densities here and in parts of Africa and east versus west and center and so on, and South America, Europe, etc. And these are the color codes in terms of humans per square kilometer. There are deep jungles and cold places where there are no humans, and of course there are population centers elsewhere. And you can see the thick cluster of the biologging sites that look at terrestrial, marine, and avian ecology. So this is data sources are from 801 publicly visible animal tracking studies from the MoveBank research platform that are likely to contain data overlapping with COVID-19 period. Marine includes seabirds and other marine species. Avian refers to all other bird species, and terrestrial are non-avian species living mostly on land. There are lots of details here that I won't go into because we can just jump into the results, and this is an example of how percentage change in humans visiting parks happened. There are many places where the numbers dropped, so those are the reddish orangish colors, and there are of course places where the number of visitors went up because the COVID lockdowns and work from home drove people crazy, and where there was access allowed to parks and where people could afford and where they were getting bored enough to get out and do something, the number of visits to parks went up. So you can see there are clusters of those in the US and Europe and some parts here in India as well. These are bound to have impacts, and this one proposes how to study the pauses and pulses of human mobility. So this paper introduced a phrase called Anthropause. Remember, we are calling the modern period since Industrial Revolution as Anthropocene, coined by Paul Crutzen, the Nobel laureate in chemistry, and this reduced human activity is called Anthropause. And the idea I want to just kind of propose is that looking at all these studies, can these be used to say what a vision for the future is if we focused concertedly on reducing emissions but also reducing human activities that impact ecologies and the environment. We need a bright vision for the future because all the alarmist messages, some of them may be quite realistic, but the uncertainties in the projections are not often mentioned clearly, which kind of bothers me, and it bothers a lot of people. And the impact has not been great either because there are a lot of people who have now climate anxiety, especially youth, who may feel hopeless about the future, which is not what we want at all. We want the kids to think about, dream about building rockets to go to Mars and beyond, and get excited about what Webb telescope is seeing and what it means for us and our future and life elsewhere and so on. So not be deathly scared about world coming to an end because of global warming. So this is just a way to look at it. And Anthropause is an unusual, substantial, temporary, continental to global scale reduction in human mobility. So this is schematically showing that, which can cause a variety of environmental responses, which are shown here, with beneficial, adverse, or no conservation impacts. An anthropopulse is, sorry, I'm used to saying Anthropocene, anthropological, so Anthropause and Anthropulse are harder to say. An Anthropulse is the reverse phenomenon that might directly follow an Anthropause, which is already happening as the restrictions are being lifted. B is the classification scheme which places human pauses along three main axes: magnitude, that is the reduction in mobility, human mobility relative to contemporary baseline levels; and spatial extent. The four categories depicted here correspond tentatively to areas spanning approximately tens, hundreds, thousands, and 10,000s of kilometers in scale, and of course duration. Early COVID-19 lockdowns and the Black Death pandemic can be classed as anthropauses, as they were events of high magnitude at global and continental scales respectively, so the red balls here. It remains to be determined, however, if subsequent COVID-19 lockdowns, grayish balls here, relatively reduced magnitude, spatial extent, and duration also fall within the Anthropause space. Placement of events in this conceptual diagram is indicative only, and resolving the magnitude scale quantitatively will require empirical benchmarking, so you need baselines with which to compare the impact of Anthropulse and Anthropause. An analogous scheme can be used to classify human pulses, including anthropulses. So we are looking here at time, just a qualitative depiction. Human mobility during the Anthropause is reduced greatly in a significant way by some measure compared to the baseline, and when restrictions are lifted, there is bound to be a bounce back effect where you get the Anthropulse, and then slowly you expect to go back to the baseline, although work from home kind of culture may end up shifting the baseline a little compared to the pre-COVID times as well. And some environmental metrics can be seen here as having positive impacts, negative impacts, or no conservation effects, and then the rebound effects again can be seen to be in the other direction for both of these. So here we are looking at the spatial extent, duration in weeks, months, years, and decades, and magnitude, low, high, and medium, low, medium, and high, with respect to some established agreed upon baselines. So scales are of course local, regional, continental, and global in spatial as well. So certain protected areas, low local years, so these are the COVID lockdowns, and Anthropause space is here, which presumably can be compared to things like Black Death Anthropause with high continental and years in terms of the scales in time, magnitude, and spatial extent. COVID-19 Anthropause high, global, and months. That's been the scale in time and space and magnitude. And successive COVID lockdowns may end up occurring at longer scales, longer time scales, smaller spatial scales, and smaller magnitudes as well. So these are just qualitative depictions. Nonetheless, there have been numerous studies which I'll just run through. Overview of the Anthropause mediated changes, reduced traffic and noise, and the posited and realized ecological effects of the Anthropause on wildlife vehicles conflict. We'll see that this is not as simple as saying reduced traffic leads to reduced wildlife vehicle conflicts. So that is something that indicates again that just reducing human activity may not be enough, that there may be things like wildlife crossing bridges needed to account for the behavioral change in the animals when they cross the road. To date, reductions in mortality and behavioral changes have been observed due to Anthropause mediated reductions in traffic volume and traffic noise respectively. So these are the Anthropause mediated changes, noise, traffic, and number of vehicles. So increased connectivity and gene flow, these are kind of qualitatively expected impacts. Reduction in invader ingress, trophic cascades, of course, because of the expanded range of grazing and foraging by animals, and we have seen elsewhere that whales, elephants, bears, etc. have positive ecological impacts. So if their range is expanded, there will be trophic cascades. Reduced mortality because of improved air quality and water quality as well. We'll see one example of behavioral change in bird singing, and increased fitness, survival, and population size because of the positive impacts. Okay, so let's just quickly run through some examples. This paper talks about a synthesis of the many studies, so distribution or abundance changes, qualitative observations and empirical data from across the globe, and you can see the various species ranging from blue jays, snow goose, white-tailed eagles to red fox, Asian black bear, great white shark, white-backed vulture, flamingos here, which I love in the Mumbai neighborhood, capybara, the big rodent, African sacred bills, pumas, Galapagos sea lions, eastern gray squirrels, green turtles, and so on. So the abstract there says the global lockdown to mitigate COVID-19 pandemic health risks has altered human interactions with nature. Here we report immediate impacts of changes in human activities on wildlife and environmental threats during the early lockdown months of 2020 based on 877 qualitative reports and 332 quantitative assessments from 89 different studies. Okay, so let's look at some more of those studies. You can read the rest of the abstract and the paper if you are interested. Air quality and water quality have been affected. So this is a Chinese study that looked at COVID-19 outbreak and the associated lockdowns and impacts on air quality. Outbreak affected waste generated by households increased because of the stay-at-home lockdown, plastic use, etc. Reduction in waste recycling because of the restrictions on vehicular transports. Medical waste increase because of all the testing and masks and so on. Consumption mode and carbon emissions changed. So obviously that's related to traffic, but also energy consumptions at home, etc. So these had negative impacts on air quality, whereas urban public transport, Spring Festival travel rush changes in China, companies and factories halting production, and decline of energy consumption overall led to positive impacts on air quality. So you can see that we always have to watch the intended and unintended consequences. Everything being ordered in, things being bought online, obviously have had a lot of negative impacts as well. This is a water quality impact from India. I think it's Damodar River. I just wanted to show again that they looked at pre-lockdown, during lockdown, and the unlock period modified water quality index, heavy metal index. This is the trophic state index, and this is some estimated risk index for ecology. And you can see that the regions that were poor or very poor got improved during the lockdown, and as soon as unlock happened, they went back to poor qualities, and here they are good qualities. Green is good here. The heavy metal index was very poor during pre-lockdown, and during lockdown parts of it improved, some didn't, and the unlock period brought them right back. Similarly for the trophic state index, these are now in mesotrophic, eutrophic, and eutrophic medium, so where nutrient pollution had bad impacts. So those are the red regions here, and you can see during lockdowns a lot of it got improved, but unlock period took it back, but not quite far back to the original pre-pandemic medium eutrophic levels. Risk indices again got much better and have improved in some regions. So the hysteresis effect or continued sustainability of the improved water quality may depend on what else changed on land, on catchment areas, and so on. This is a sea turtle study and their suitable habitat for spawning and so on. They tried to separate the temperature effect and the visitor density to the beaches where turtles tend to come in for laying eggs and breeding. So number of turtles within 100 meter of the habitats we were looking for. There is a temperature effect which is presumably natural. Of course this would be shifting because of anthropogenic warming and so on, but you can also see that as visitor density drops, as visitor density increases, number of turtles within 100 meter drop off. So that's consistent with what we expect. But the story is obviously a bit complicated. This says elevated wildlife vehicle collision rates during COVID-19 pandemic. Wildlife vehicle collisions threaten both human and wildlife, but we still lack information about the relationship between traffic volume and wildlife vehicle collisions. The COVID-19 pandemic allowed us to investigate the effects of traffic volume on wildlife vehicle collisions in the United States. So probably it's very region specific in that sense in terms of people's reliance on personal vehicles. We observed decreased traffic nationwide, particularly in dense populated states with low or high disease burdens. Despite reduced traffic, total collisions were unchanged between wildlife and vehicles. Okay, wildlife vehicle collisions did decline at the start of the pandemic, but increased as the pandemic progressed, ultimately exceeding collisions in the previous year. As a result, nationwide collision rates were higher during the pandemic. We suggest that increased wildlife road use offsets the effects of decreased traffic volume on wildlife vehicle collisions. Thus, decreased traffic volume will not always reduce wildlife vehicle collisions. So we need to think of other things like crossing bridges, safe bridges to cross, etc., because reduced traffic probably enticed the wildlife to use the roads more and more, but over time they just started to be exposed more to vehicle collisions. This is an example from Hawaii which shows that the reduced visitors and banned diving activities and so on ended up producing some good impacts. So they compare mean fish density and mean fish biomass before COVID Tuesday, during COVID closure and post-COVID open. So you can see that various species in sectors like backdoors, keyhole, channel, and witch's brew. These are the locations, and you can see the impact of increased post-COVID COVID closure and post-COVID number of individuals as well as mean fish biomass. So some of them drop off and some of them remain keep the positive effect for some time. Okay. Another example, singing in a silent spring, birds respond to a half-century soundscape reversion during the COVID-19 shutdown. We saw this in the schematic before. Actions taken to control the coronavirus disease COVID-19 pandemic have conspicuously reduced motor vehicle traffic, potentially alleviating auditory pressures on animals that rely on sound for survival and reproduction. Here, by comparing soundscapes and songs across the San Francisco Bay Area before and during the recent statewide shutdown, we evaluated whether a common songbird responsibly exploited newly emptied acoustic space. We show that noise levels in urban areas were substantially lower during the shutdown, characteristic of traffic in the mid-1950s, so traffic was much less before. We also show that birds responded by producing higher performance songs at lower amplitudes, effectively maximizing communication distance and salience. The importance. These findings illustrate that behavioral traits can change rapidly in response to newly favorable conditions, indicating an inherent resilience to long-standing anthropogenic pressures such as noise pollution. So good news and bad news that resilience seems to be high, but we don't know how long that will last as we keep putting pressure on acoustic spaces, physical spaces, habitats, and so on and so forth. This is the mountain lions, which argued that the traffic usually inhibits mountain lions in their range. So this is COVID-19 shelter-in-place order that brought about reductions in traffic and enhanced the range of predation of the mountain lions towards human habitats. This is an example of sound pollution from Dublin, Ireland, which looks at pre-lockdown and lockdown sound levels with some measure that I'm not going into, but you can see that there is a systematic reduction in sound pollution in various parts of the city, which again is consistent with how birds would respond to such a situation. It's not just the noise in the air, there is also evidence of reductions in underwater noise in this paper. A slowdown in global trade activity due to COVID-19 has led to a reduction in commercial shipping traffic into the port of Vancouver. The Ocean Networks Canada Observatory System provides researchers real-time access to oceanographic data from a wide range of instruments, including hydrophones located along the offshore and inshore approaches to Vancouver. Measurements of power spectral density at 100 Hz from 4 of these bottom-mounted hydrophones are presented, along with AIS data and shipping and trade statistics to assess to what extent the economic impact of COVID-19 can be observed acoustically and in real time. The quarterly trend medium weekly noise power in the shipping band of frequencies shows that a reduction in noise commensurate with the economic slowdown has been observed at 3 of the 4 hydrophone locations. Okay, there you go. This is again restrictions provide a brief respite from the wildlife roadkill toll, but as we said, this can be complicated because the vehicle wildlife collisions can go up if animals are misled into thinking that now roads are completely safe. I don't know why I put this again. This is another example of the beach ecosystems that were looked at in all these places in Mexico, Panama, Colombia, Brazil, Cuba, and Puerto Rico. And they looked at various bioindicators, activities, litter, noise, and odors in terms of qualitative assessment of degradation of these things. Towards grading of 5 is worse and towards yellow is better. So bioindicators before and during show systematic improvements in the reduction of poor quality bioindicators. Activities also show beneficial effects. Litter shows reduction, noise shows reduction as we saw, odors show reduction, a large reduction as well. So this should serve as a good example of how, if we continue to modify our behavior, our activities, our transportations, our food production, pollution, air pollution, noise pollution, etc., how we can actually be good conservators, stewards of the environment. So we have negative effects, of course, across the board, but biology finds the loopholes, and this may be also a good way to look for how biological loopholes are exploited, how refugia may have formed during human activities, and how we can recover conservation efforts based on what worked during the COVID-19 lockdowns. Okay, does this help us to provide a vision for the future about what we can look forward to if we do well in our conservation efforts and reducing our environmental footprint? Then yes, this is a good way to monitor things and learn when an unintended experiment showed just how much impact we have and how various species and air and water qualities and so on respond quickly to our own reduced impacts. Okay.